Hello, student. Okay. Today we will go into LU2, and this week we will use online teaching for this topic. So, so this is a subtopic under this LU2. We have equation, inequality, and absolute value. So now we look at the first subtopic, equation. Okay, so this is the learning outcome. The student, you can read this by yourself. Okay. We need to understand what is equality. So equality is a relationship accepting two quantity having the same value or represent the same mathematical object. Right? We use the equal sign, right, to express equality. So A equal to B. Okay. Equality is also as a statement. So equality is a statement with true or false value. Okay. 2 plus 3 equal to 5 is a true statement. Okay. However, 2 plus 4 equal to 5 is a false statement. Okay, now we come into equation. Okay, so what is equation? So an equation is a statement of equality involving one or more variable. Okay, for example, 2 plus x equal to 5 is true if the value of x is 3. Okay. Another way, 2 plus x equal to 5 is false if x equal to 4. So an equation, then is a condition statement since its true value depends on the value of its variable. Okay, so what is solution to equation? So the numerical value of the variable that result in the equation begin true is a solution of the equation. So x equal to 3 is a solution or root, right, of 2 plus x equal to 5. Okay. Since we substitute x with 3, okay, make the equation a true statement. Okay, so when we substitute x is 3, okay, so your left hand side x plus 3, you get 5. Okay, so your right hand side also equal to 5. So this equation is true. Okay, solving an equation is a process of finding all the solution to the equation. Okay, so okay, we learn a little bit on the property of equality. So reflexive, okay, we have two value a equal to a. Okay, symmetry, we can change the position from right hand side to the right hand side, and the equation is still the same. So for example, a equal to b, b equal to a. Okay, transitive. Okay, if you have two equation, a equal to b, b equal to c, we can conclude that a is equal to c. Okay, substitution. Okay, we have a equal to b. If we substitute to any expression of fx, so you will get fa equal to fb. So equivalent equation. Okay. Substitute property allow us to write equation equivalent to a given equation. So two equations are said to be equivalent if they have exactly the same solution. Okay. For example, 2 plus x equal to 6 and 2x equal to 4 are equivalent equation. Okay. So for example, we minus 2, left hand side, right hand side. So what you can see, minus 2 plus 2 plus 2x equal to 6 minus 2. So you will get 2x equal to 4. So this one, eh, exactly like another equation given. So this 2 is a equivalent equation. Okay. So some discussion on the step of solving, right? Student A when they explain to student B. So student A, okay, he's always used the move. Okay, for example, right, he moved the positive 5 to the another side to become negative 5. Then he moved multiply 2 to another side to become divide 2. And the last step, it moved the square root to another side to become power 2. Right? So question student B raise up a question. Okay, are you sure that it's a good way to say your answer? Because if student who never learned mathematics before, so when you say something like this, okay, they will be confused. So how are we going to make it more clear? So it's better we use subtract both side with 5. Okay, rather than we say move positive 5 to another side become negative 5. And then it's better that we say divide both side by 2 instead of we say move multiply 2 to another side become divide by 2, right? And square the both side, right? So when we do this, okay, is avoid us to make careless mistake, right? So because sometimes when you move one value to another side, okay, you may forget to change the sign, right? So if you subtract both side with 5, so you know, okay, it's equal, right? Left hand side equal to right hand side. So it will reduce your chances to make a careless mistake. Okay, now we come to the example 1. Okay, solving the equation 3x minus 5 equal to x plus 3. So we use the correct habit, okay? Plus 5, left hand side, right hand side. After you simplify, you subtract variable x, left hand side, right hand side. So lastly, okay, we divide left hand side, right hand side with 2. Okay, here we have the solution. Okay, x equal to 4. So we test our solution by substitute back to the given equation. So we check the left hand side and the right hand side. Okay, are we getting the same value or not? So this solution, right, after we substitute it to the left hand side and right hand side, so he yield the same value, which is 7. So x equal to 4 is a solution. Let's look at a second example. Right? The rationals equation. So what we need to do is we want to eliminate the denominator x minus 2. Right? So the good way to do this is we multiply both sides with the denominator x equal to 2. Right? So after we simplify, okay, we subtract x, right, both sides, then divide by 2 both sides, you get x equal to 2. Okay, however, when we check the solution by substitute back to the given equation, right, we find out that right, this x equal to 2 is uh, not permissible. So what is mean by not permissible? Okay, let's look at what happens when we substitute, when we have x equal to 2, right? Your denominator is x minus 2. So x minus 2, right? If you substitute it 2, right, you will get 2 minus 2, which will give you 0. So recall back, student. So what happens if you have eh, 0, 1 plus 6, 0? So what happens if you do this? X, Oh, sorry. Okay. So what happens when you have the okay, so the denominator zero. So this one will give you undefined, right? Okay. So that's why we say that x equal to 2 is not the solution. Okay. Okay, so here is some simple exercise that you can do it yourself. Okay. Uh, okay. And then we give you the answer. Okay. So you try yourself, see whether you get the x value or not. Okay. So just now we have done the uh, linear. Okay. Now we go to quadratic equation. So quadratic equation, we have the equation in the form of ax squared plus bx plus c equal to 0. So a quadratic equation is a unit variate equation having only one unknown. Okay? Commonly is x. So a quadratic equation is a polynomial equation of second degree. Okay? So you will learn this what is second degree in your um, LU3 later on. Okay. So in the standard form, we can divide the term, right, into three term. Okay, we have the quadratic term, okay, linear term, and constant, or we call it a free term. Okay. So the equal sign, okay, equal to 0. And then A, B, and C also have a specific name. Okay. A in the quadratic term, we call it quadratic coefficient. B is a linear, uh, bx in the linear term. So B, we call it the linear coefficient. And C is, we call it constant. And so there is a three method to solve the quadratic equation. I believe you have learned this in your school. Okay? So we have factorizing, completing the square, and quadratic formula. So first, we look at how to solve using factorizing. Okay? So we use the zero product property. So how to read this mathematics sentence? Okay? So the product of two algebraic expression, P multiply Q is equal to 0. Okay? So if and only if. Okay? So this is if and only if. Okay? So this one is if and only if. Okay? P equal to 0. Okay? Uh, or Q equal to 0. Okay? So means that if and only if at least one of the expression is equal to 0. Okay? Solving by factorizing. Okay? So first we write the equation in the standard form. Okay? Standard form means we arrange everything in one side equal to 0. Uh, so factorize the quadratic expression. Okay, apply zero product property, and then we get able to solve the individual factor to find the solution. Okay, now we go to equation example 3. So 3x squared equal to 10 minus x. So first, we have to write it in, arrange it in the standard form. So ax squared plus bx plus c equal to 0. So this one, the standard form, ax squared plus bx plus c equal to 0. And then we try to factorize using the factorize method. Then we solve the factor uh, individually, apply the zero factor theorem, so we're able to find the solution. Okay, so here there is some exercise for you to practice, okay, to recall back what you have learned in your secondary school. Okay? The same thing, we have the solution for you. Okay, the second method, solving by completing the square. Okay, so completing the square method require us to have the monic equation, quadratic equation. Okay, what I mean by monic means that your quadratic coefficient a must be equal to 1. Right? So in order to complete the square of the quadratic expression, the quadratic expression have to be in the monic form. Right? The standard quadratic equation can be written in the monic form. So how? Okay? By dividing the whole equation by the value of quadratic coefficient. Okay? So you will get your quadratic term with a quadratic coefficient 1. Okay? So this is our standard form. Okay? And then before you apply the completing the square, your a must be equal to 1. Okay? So this is the monic quadratic equation, when your a equal to 1. Okay? So supposedly we have an expression of x plus h equal to 2. Okay? So why we call this expression? Because they don't have equal sign. So when you have equal sign, okay, for example, equals 0, so we call this a equation. Okay. So we expand this expression, and we call this is a perfect square. So if you have compare with the uh, standard form, so your 2h will be equal to b, and then your h equal to b over 2, and therefore we will get this equation after we substitute your h b over 2. Right? Since we know that this equation, we can manipulate any monic quadratic expressions such that right, this way. Uh, So as you can see, this is the right, completing the square, important part of the completing of the square. Uh, so later we use the example to explain. Okay? So you have to plus b over 2 square minus b over 2 square. And so now here is the step to solve the completing the square. Okay, write in the monic form. perform completing the square, then solve for the x. Okay. So example 4. Okay. Solve the equation. Okay. So you must change your equation to the modic form by dividing every term with a equal to 3. Your quadratic expression coefficient a equal to 3. Then you're completing the square. So as I say here, you must add square b over 2, okay, and minus b over 2. Okay. So we don't change the value, any value of the equation, because plus over 2 square minus b over 2 square actually, you cancel out each another. So you will get back the original equation. Okay. So we solve this in two parts. The plus b over 2 will give you the x minus 5 over 6 bracket square. And the constant part, the minus b over 2 square, will give you this constant value negative 1 over 36. Okay. So now we can solve for the x. So add 1 over 36 both sides, square root both sides. Okay, so once you do the square root both sides, don't forget plus minus square root. I believe this one you are familiar when you do your square the both side in your secondary school. You need to put a plus minus. Okay, then you plus 5 over 6, okay, both side. Okay. So because of plus minus, right, you will get two solution. So that is the answer for the completing the square. So I believe in your secondary school, your teacher used the formula, mean that you skip this part, right? So in university, right, we we have to use this uh, b over 2 square minus b over 2 square, right? Because we want you to understand, okay, where is the formula come from, right? So make sure student take note, right? This step, okay, we will give mark, when you write this during exam, right? I know a lot of school teachers, okay, they skip this, right? Straight away they go to the last, right? The last section, by using the formula. So so as a university student, we need to know, okay, how this thing form. So you need to know the basic, So important for you to know the basic. Okay, so now there is uh, completing the square exercise for you to try by yourself. Okay, so the answer is also given. Okay, now we look at the solving by quadratic formula. Okay, so completing the square can simply be applied on the general non-monic quadratic equation. Consider the standard form, ax squared plus bx plus c equal to 0. Right? Divide the both side of the equation. Right? Okay, this is the monic quadratic equation. And simply apply the technique to solve by completing the square will help us to get the quadratic formula. So you can read yourself. Okay, so just now you already learned how to use completing the square. So we apply the completing the square, and we rearrange the whole equation in order to get the x. So now in the school, before this, okay, the teacher only give you the formula, which is x equal to minus b plus minus square root b square minus 4ac over 2a. And many of us do not know where it's come from. Okay, so I now tell you it's from the completing the square. Okay. So this is the step to solve a quadratic formula. So write it in the standard form. So if you use the formula, so no need to get it in a monic form. Okay, you just need to list down, okay, what is the quadratic coefficient, what is the linear coefficient, what is the constant, then substitute the value in the formula. Okay, so this method is very useful, for you to solve the x solution. Okay, if your factorizing cannot factorize. If you cannot factorize, you can use the quadratic formula. So this example, right? We list down, right? After you rearrange in the standard form, we list down all the coefficient. Then we substitute in the formula, and it gives us the solution. Okay. So here is the equation, exercise 4, that you can practice your quadratic formula. So that's all for the class today. So thank you, class. Right. So this week we have three classes. Right. 2 hours, 2 hours, and 1 hour. Right. So you will have three video. Okay. So this is the first video. So after you watching this, okay, don't forget to tag your class attendant. Thank you and have a nice day.